Hi, my name is Jakub Kubajek, and I'm going to show you today how to save your time by automatically extracting the most important information. Currently, I work at the Samsung R&D in AI team. However, this presentation will be about the new summarization model that I developed during my work at the Chancellery of the Prime Minister of Poland. The main idea behind this model was to provide the government with the information about the most important topics in the media on a particular day. During this presentation, I will try to explain the most important steps in the new summarization model, and I will try to explain how they produce the good output of this in the summarization. But first of all, I would like to answer why I choose unsupervised learning for this task. When it comes to supervised learning and natural language processing, we have nowadays a lot of pre-trained models, but they are mostly for English. And we have lack of models for Polish and other languages. Furthermore, there is lack of training data for other languages than English. And as I said, I was working at the Chancellery of the Prime Minister, and we didn't have access to GPUs, so we couldn't train our own models, or we didn't have linguists to create our own data sets. And last but not least, the summarization problem of news is complex. We have the multi-document problem, so it means that we cannot input 300 articles into single neural network and just have the summarization, the abstractive summarization. So the answer is obvious. We need to use unsupervised learning. Before I will go deeper into the pipeline of the model, I would like to explain keywords that I will use during this presentation. First of all, when I use the word, when I say token, I mean word. It's not always true, but for the purpose of this presentation, token means word. Lemmatization is a process of reducing a word to its basic grammar form. It is very important in languages such as Polish. TF matrix is a matrix that contains row counts of terms in this context, tokens or words, occurring in a set of documents. IDF is a measure which downscales words that appear very frequently in many documents. And embedding, it's a kind of representation, a numeric representation of a word. And cosine similarity is a measure of the similarity between two vectors, where value of 1 means that the two vectors are mostly the same. -1 means that they are negative, they have negative directions, and 0 means they have nothing in common. So now the pipeline. Before we process the articles, we need to scrape them. Then we have the pre-processing of the articles. I need to explain the colors also, because the model was developed in both Python and R, and yellow means Python and blue means R. So scraping was done with Scrappy and pre-processing with tidy text. Then we have to identify the most important words on a particular day. If we have important words, we need also dimensionality reduction. As I said, we have 300 articles, and these articles usually have 10 paragraphs. So we have many dimensions, and if we have many sides, we have many columns in matrix. So we need to reduce the dimensionality. If we have the important words and also embeddings, so the vector representation of words, we may start to cluster them into topics. If we have topics, so the consistent groups of words, Then we may start to summarize them with the use of LexRank, which I will describe later on. And at the end of the pipeline, there is output with the report. I would like to start from the word's importance. In 1993, Ted Dunning proposed to identify bigrams with the use of likelihood ratio test. But the same idea, the same approach may be used to identify whether the word appears more frequently today than it used to be during, for example, the whole last year. And this approach is good for words because it doesn't have has the assumption of normal distribution. It is the assumption of binomial distribution of words. So it assumes that words appear according to binomial distribution. And this is this function. It compares two parameterization. So we compare whether there is only one frequency of word combining our current day and the reference period, or we have two separate frequencies. One, P1 for our current day, and P0 for the reference period. And the statistics of -2 logarithm lambda has the chi-square distribution. So it can be used for identifying identifying the important words. The only modification in this measure that I applied was to scale by -1 words that appear less frequently than in the reference period, because the statistics test whether there is a difference between frequencies. And we have also the other, so we select the words that has statistics higher than 10, and we also demand that these important words are amongst 10% of the most frequent word in a particular day. Now I would like to move into embeddings. And this was done with the use of singular value decomposition. Because it's pure algebra, it's very fast, and it can be used without any training, like it's in the case of word2vec or globe. All these other approaches require to train a neural net. And this approach is very simple and is very fast. But it still captures the semantic relationship between words. So even if we have, for example, two words, dog and cat, and they doesn't appear together in the same articles, but when there is cat mentioned, there are also words associated with animals, raising pets, and domestic animals. And the same is with dog. If we have dog, we have words about animals, pets, and etc. So at the end, the embeddings of these two words would be similar, because we reduce paragraphs and articles into lower dimensionality. Clustering. I think this is very important part of this model, because summarization is one thing, but we need to identify really consistent topics. And for this task, I've chosen to use agglomerative hierarchical clustering, because it's approach that doesn't require to specify number of clusters at the start of the algorithm, like it's in the case of, for example, k-means. So, as I said, it's agglomerative hierarchical clustering. So we start with n topics, when n is the number of words. Then we try to find two most similar words. And the similarity is measured by the cosine between embeddings. If we have these two similar words, we group them into topics. And the topic has new embedding that is a sum of the two words embeddings. And we stop when we have only one topic, so we group them all together. And we decide how many clusters we have by applying silhouette algorithm. This is an algorithm that tries to assess the inner similarity and the outer similarity, and to find clustering in which objects are the most similar to each other, are the most similar to each other inside the cluster, and the most dissimilar to the closest topic outside. This is an example that I created for the articles from BBC. As I said at the beginning, the model was created mainly for Polish, but it can be applied to other languages. In this case, English. I scraped articles from the last week from BBC, and this is the second most important topic on BBC last week. It's the legal case between Elon Musk and Vernon Unsworth. Vernon Unsworth is a British diver who helped to rescue 12 boys from cave in Thailand last year. And Elon Musk called him a pedo guy. And this was this legal case concerned this tweet about being pedo guy, by Vernon Musk called the Vernon Unsworth a pedo guy. So we can see that we have all these words, all these important words here. So we have Musk connected with Unsworth, Unsworth connected with cave. And also Musk is connected with tweet, and there is also word pedo. I will return to this example at the end, and I will show the summary, the automatic summary found for this topic. But before this, I would like to explain the summarization tool applied in this model. As I showed during on the pipeline of the model, the algorithm applied here is LexRank, and the LexRank is based on Google's fundamental algorithm, PageRank, which was a breakthrough in 1998, which allowed Google to be the best search engine at the beginning. And PageRank is used to rank websites with the use of Markov chain. So the ranking, the output of the algorithm is the steady state of Markov chain. And the Markov matrix is a weighted mean of random matrix, and matrix consisted of links between pages. And the LexRank used the same approach. It also used the Markov chain and finds steady state of the matrix, but instead of matrix of links, it used matrix of cosine similarity between sentences. And the matrix that is used to build the cosine similarity matrix is TF-IDF. However, and generally, LexRank is a very good algorithm if you want to summarize single document. It will find really good sentences if you want to summarize a novel. But in the case of multi-document sources, like news, we have to filter out only articles that contains topic words. And if we do so, then the IDF part of the matrix would downscale the importance of the topic words. And we don't want to do so, because then the topic words would be unimportant, and because they appear very frequently in our sentences. But we still have a measure of importance. As I said, there is a Dunning measure, or the log likelihood ratio test. So we can, so instead of IDF, we can use the output of this test. Furthermore, we can also calculate cosine similarity between particular word and topic to include more scaling of the frequencies. And this scaled time frequency we may use to calculate the sentence embedding, which is a dot product between scaled time frequency and words embeddings. At the end, when we have ranking, we may still scale this output and upscale sentences that contains many topic words and downscale long sentences. And last but not least is sentence selection, because we don't want to select duplicated sentences. So we just need to compare recursively, going from the most important, and select, so for example, K, most important, not duplicated sentences. And we just compare the cosine similarity between sentences. And as I said, this is an example for this legal case between mask and unswerve. So we have three sentences, and they contains the main words like pedagogy, tweet, and card. So we can understand that this topic is about a legal case, and we also know what's the main field of this case, what was the main issue. If you would like to get deeper into the model, or see an example of the report, or use the model by yourself, it's published on GitHub on my repository. So if you would like to take advantage on it, feel free and download the repository, and yeah, and that's all. Thank you very much.
Thank you. Any questions? One.
Why was the model developed using both Python and R?
It's because at the Chancellery we use primary R to use any scripts. So the R is like the main steering script, which evokes script written in Python. So Python runs in the background. So this is the, let's say, the company culture. And the Python helped to accelerate this model a lot.
Okay. Next question.
So is the model actually on production?
Yes. It's
and do you know how it performs in real life? Is it really a value for your customer?
Yes, I think it helps to identify the topics that are hot in media, because we had a problem at the Chancellery, because we were to check the medias to read newspapers and to maybe not control, but to be in touch what is going on in media, what's very important to news, etc. And it was very hard to find really relevant information and to assess whether it appears more frequently than it used to be. And it's this model, after 8 months, it's still working at the Chancellery. So I think it's the model that boosted somehow the way the Chancellery works.
Anyone?
Do you evaluate somehow this model? Because I know that there is similar model, it's called TextRank, and maybe you compared it with it somehow?
Yes, generally TextRank is only the idea, and they are very similar to LexRank. But LexRank use scaled TF matrix, and TextRank use the similarity between words in sentences. So not exactly the TF matrix or sentence embeddings, but only overlapping of words. So it was the main idea of TextRank. But they were published in the same year, and I think they are very similar. The idea is the same.
Okay, next question.
Hi, thank you for this speech. And as I have a question which is follow-up on the previous question, is your client counting how many important events in Poland are missed by your algorithm? It's not offensive. I'm just
No, I
asking out of
understand.
curiosity.
I think not. This is not the this is not the oracle, and it's only a tool that helps to make the work faster. So there are still people who assess these reports, and if there is a topic that needs to be scrutinized, it's done by human, not by algorithm.
Okay, thank you. And one more technical question, because you mentioned word embeddings, and also you mentioned that you don't have access to GPU to produce own embeddings. What was your source for word embeddings?
No, these embeddings are created every time, based on
okay.
articles, on the frequencies in articles and in paragraphs. So I don't use Word2Vec or Glove.
Okay.
So that's the composition of the matrix, of the TF matrix, composed of where we have in rows particle words, and in columns we have paragraphs and articles.
Okay. So maybe you considered using pre-trained models, because there are some available even by fast text.
Yes, but the idea behind this is that we have the term frequency matrix, and we need to create embeddings for a particular day. So we cannot use Glove or anything that is general. We want to compare these embeddings for a particular day. And we cannot use also these more complicated neural networks embeddings because there are even some analysis that shows that this, for example, neuron Word2Vec performs very poor when the corpus is small, and we have 300 articles more or less every day. So we don't have billions of words like it was used to train Glove.
Okay, I don't mean training, but using existing one. But that makes sense not to use this big matrix for such a simple task. Okay, thank you.
Next question.
Thank you very much once again for this presentation. Do you think algorithms like this can be used, can be scaled and used for invigilation? maybe for reading text message, like and thinking what's going on in the society.
But do you ask about Poland or general?
Mostly about governments.
I think
Worldwide.
governments
Worldwide.
doesn't have how to say the knowledge to use this in the way you asked. So this is not an issue in when it comes to governments. Maybe Secret Service, but not the government.
Okay, thank you.
Okay. Next question. Anyone? Okay. Thank you. Thank you.